Hello friends, today I'll discuss about function of the Buchholz relay in a power transformer. How the Buchholz relay is works under normal condition and under fault condition. So in order to understand this, please go through the video.
Normally, Buchholz relay is mounted in between the pipeline which is connected the main tank of the transformer and the conservator tank. So this is the Buchholz relay. So what is the purpose of the Buchholz relay? Buchholz relay mainly detect the three types of fault. One is the incipient fault due to which the fault current is very minimum and differential relay and the IF relay is unable to detect this type of fault. Number two, that is the interturn winding fault, short between interturn winding, which result very minimum amount of increase in the fault current. So again, the differential relay is unable to detect this kind of fault. And number three is the internal fault or internal short circuit, due to which hydrocarbon gases will be generated, and these hydrocarbon gases will try to flow from the transformer main tank towards the conservator tank through this pipeline, and it will be catch in the upper portion of the Buchholz relay, and Buchholz relay will give the alarm and trip signal to the circuit breaker depending upon the severity of the fault. So in this figure, the construction details of the Buchholz relay has been shown. It is like one is a dome-shaped structure. So this is the inlet valve and this is the outlet valve. Under normal conditions, if oil in the transformer main tank get heated, then some of the oil will flow from the transformer main tank towards the pipeline which is connected between transformer main tank and conservator tank through the Buchholz relay and towards the conservator tank. So this is the road or this is the pipeline through which the oil from transformer main tank to the conservator tank will flow. So in the Buchholz relay, there is a flap type arrangement which is fixed in a hinge point, and from this we have a one mercury switch. So it is aligned in a position that this 2 point get not sorted by the mercury. So this 2 point is connected by a wire and it is connected towards the control and relay panel for giving the trip signal at the CRP panel. And another hinge or float, another float is connected from the hinge point in the upper portion of the Buchholz relay. Again, in the float, we have again another mercury switch which is fixed in the upper portion of the float. So again, we have a 2 point. This 2 point is connected by means of cable towards the CRP panel. If this 2 point is sorted by means of the mercury, then a alarm signal will be given in the CRP panel as a Buchholz alarm. So under normal condition, the inner portion of the Buchholz relay is filled with transformer oil, and due to filling of the transformer oil, the float will be remain in such a position that this 2 point will not get in contact via mercury in the mercury switch. Again, the trip contact or trip mercury switch remain in such a inclined position due to presence of the oil, transformer oil in the Buchholz relay. The mercury in the mercury switch remain in a one side, so that these two contact are not conducting path by means of the mercury, and there is no trip signal will be given in the CRP panel. So this is the position of the float and the flap. Uh, that is the two mercury switch. One is for Buchholz alarm and another is for Buchholz strip under normal condition. Now during internal fault condition or during interturn short of the winding, hydrocarbon gas will be generated, and this hydrocarbon gas will be flowed from the main tank towards the transformer conservator tank. So during flow of this type of hydrocarbon gas, while flowing from the pipeline from transformer main tank towards the conservator tank, this gas will be in light in nature. This gas will be trapped in the upper portion of the Buchholz relay. So since these gas are light in nature and oil is heavier than these gases, so upper portion of the Buchholz relay is filled with this hydrocarbon gas. So due to which the float will be downwards and it will be come to the horizontal positions and initiate and due to this these two contact will be get conducting path via mercury in the mercury switch, and it will result in initiation of the alarm in the CRP panel, that is the Buchholz alarm, that is the indication of the internal fault of the transformer. Now, when the internal fault is severe and there will be generation of the hydrocarbon gas in plenty quantities. So, due to generation of the huge quantities of hydrocarbon gas, this hydrocarbon gas will, along with the transformer oil, will flow towards the pipeline towards the transformer main tank, and due to this, it will it will give a thrust to the flap point of the mercury switch, and due to this, this switch along with this flat comes to the horizontal position, and which result the mercury in the mercury switch to give a conducting path in between 2 points, which is result a trip initiation to the control and relay panel, and the Buchholz a auxiliary relay which is connected by means of this two cable will be actuated, and this relay will give a trip signal to the circuit breaker in order to trip the power transformer under Buchholz trip.
So friends, this is the purpose of the Buchholz relay. So if you like my video, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video.